This is a just-in-time learning video for the unit circle. Let's take a look at how our unit circle is set up. At this point in time, you have already looked at relationships between your 30-60-90 and 45-45-90 right triangles. Our unit circle is based on that information. Here, you can see that I have shown the x-coordinate and the y-coordinate of the point where the radius of unit 1 intersects the circle. This is a unit circle because the radius is 1. In this just-in-time learning, this is really just to help you get a grip on all of the different values that are associated with the unit circle. What you see in black are things that are probably intuitive for you. What I'm going to help you build quickly are the blue and the red. Let's start with the red. If you think of the red, the very first mark is going to be pi over 6 or 30 degrees. I'm going to do everything in terms of radians. You can go back and match up the angles afterwards. But if you think of all of the red marks as multiples of pi over 6, this next red mark would be 2 pi over 6, which happens to be pi over 3. 3 pi over 6 would be pi over 2. 4 pi over 6 would be 2 pi over 3. 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, or 4 pi over 3, 9 pi over 6, 10 pi over 6, or 5 pi over 3, and 11 pi over 6. 12 pi over 6 takes us to 2 pi. Now let's work on the blue. With the blue, we start off at pi over 4. 2 pi over 4 would be pi over 2. 3 pi over 4. 4 pi over 4. 5 pi over 4. 6 pi over 4. 7 pi over 4. And 8 pi over 4 takes us back to 2 pi. All right, now what we want to do is associate the ordered pair of the point with the radian measure. What you can see is that I've put just a couple of our points on, and those points will help us find all of the points that we need. Let's start off with the blue. In the blue, you can see that I've marked pi over 4 at the square root of 2 over 2, square root 2 over 2. All of the points in blue are going to have those coordinates. It will just be the signs that will be impacted depending upon the quadrant that they're in. Let's think about 3 pi over 4. 3 pi over 4 will have a negative first coordinate, or negative square root 2 over 2, and then positive square root 2 over 2. Remember, your ordered pairs are x, y, and you must remember where you have positive or negative values in the quadrant. At 5 pi over 4, both our x and our y would be negative. And at 7 pi over 4, only our second coordinate would be negative. All right, let that sink in for a second and see if you could anticipate what the red ordered pairs would be. Okay, so let's go ahead and take a real quick look at how this is all set up. One of the things that you're going to notice first is I'm going to go ahead and put the red radian measure back in. Now that I have my red radian measure in, all of the values for the ordered pairs are going to be based off of what I see to begin with. That square root 3 over 2, 1/2 is going to drive the rest of this. So how does it drive the first one? With pi over 3, I simply reverse them. 1/2 square root 3 over 2. When I move to the second quadrant, 2 pi over 3 and pi over 3 are going to have the same values, except negative 1/2 would replace 1/2, still have square root 3 over 2. When you come down to 5 pi over 6, 5 pi over 6 is going to have the same values as pi over 6, except we're going to have negative square root 3 over 2, positive 1/2, because in the second quadrant, the x value there is negative. Moving down to 7 pi over 6, I bet you could guess already that both the x and the y coordinates are negative, and they too are aligned with pi over 6. Coming down to 4 pi over 3, 4 pi over 3 will have the same coordinates as pi over 3 and 2 pi over 3, except both of those will be negative. So now we're talking about negative 1/2, negative square root 3 over 2. And for 5 pi over 3, well, the x-coordinate is going to be positive, so that would be positive 1/2, but the y-coordinate is in fact negative, square root 3 over 2. We're left with just, at this point in time, 11 pi over 6, and I think you might realize that 11 pi over 6 is going to line up again with pi over 6. Therefore, the first coordinate is going to be positive, the second coordinate is going to be negative. Now, it looks like a lot of numbers, but what I want you to focus on are the relationships, because building that correctly every single time does not take a lot of talent or even a lot of memorization. If you know pi over 6 and you know pi over 4, you can get this whole unit circle done just by thinking about the multiples of pi over 6 and pi over 4 and the ordered pairs that would be associated. All right, so here's our completed unit circle. A little bit messy because we built it, but the whole idea is you will want to build this over and over again so that these values in this circle is committed to memory. On any test where the unit circle is needed, my best suggestion is immediately after you're given the test, draw your unit circle and put all of the information on it. Now that we've built our unit circle, what's most important is that we understand that the ordered pairs on the unit circle give us some very key values. Every ordered pair is set up cosine sine. For example, if I asked for the sine of pi over 6, you would locate pi over 6 on your unit circle. The second coordinate is 1/2. Therefore, the sine of pi over 6 is 1/2. Again, go back and remember your right triangle relationships. And I know that some of you have been thinking a lot about SOHCAHTOA. That's where this is connecting. What if I asked for the cosine of 5 pi over 3? You would locate 5 pi over 3. The ordered pair at 5 pi over 3 is 1/2 negative square root 3 over 2. Therefore, the cosine of 5 pi over 3 is 1/2. Let's end with just one more example. Suppose I asked you to find the tangent of 3 pi over 4. What would you do? Well, the very first thing that you would do is on your unit circle, you would locate 3 pi over 4. And at 3 pi over 4, the ordered pair is negative square root 2 over 2, square root 2 over 2. At 3 pi over 4, with that ordered pair, you also know that the cosine is the first coordinate and the sine is the second coordinate. If you wanted to use the relationship that tangent is the same as the sine function over the cosine function, you would be able to set up very quickly that the tangent of 3 pi over 4 is equal to the square root 2 over 2 over negative square root 2 over 2, which I hope that you would see reduces all the way down to negative 1. So the tangent of 3 pi over 4 is negative 1. I'll be posting some other quick videos of workout solutions for you. I hope this one gets you in line quickly, though, with how to go about really understanding how the unit circle is set up.